like a day or a week or a 2-week iteration or whatever. And here is what people want you to do. Set, look, right? And it's almost always like that, especially in software, because people don't get how hard software can be. And so therefore, the first thing you have to do is have a never list, okay? And you have to understand that never is a proper answer to people who ask you for things. And the next thing you have to do is not just accept stuff if it's a good idea, but only accept stuff at the rate that you finish stuff. So your accepting criteria is you can, if you're doing 10 a month, you can accept 10 a month and no more. If you're doing 20 a month, you can accept 20 a month and no more. So you have this buffer, okay? Because everything else you won't get done anyway. So you have this buffer, and the purpose of the buffer is to queue up enough stuff, not very much, but enough stuff so you never run out of work. So if you have a steady stream, you don't need a very big buffer. And you want to know how long that buffer is, because if this buffer is 2 weeks, then in 2 weeks you can start working on something. If it's 3 weeks long, it takes 3 weeks to get through. If it's 5 weeks long, it takes 5 weeks to get through. So you know how long this buffer is. And therefore, when something comes in, you say either, sorry, don't have capacity, or it'll be done in 3 weeks. So you promise date, or you say no. That's how you deal with this thing called backlog. So instead of a backlog to park stuff, so you don't have to think about it, you want a way to accept work coming in at the same rate that work is going out. Now when you're working with much larger projects, there's more sophistication required that I won't go into, unless you push me to. But the concept is to accept work at your output rate and to have a small amount as possible of stuff queued up to do so that everything you work on is fresh. So in Lean in general, anything that is a stack of stuff, whether it's inventory, whether it's lines you wait in, I don't care what it is, it's bad. It's just considered, you know, bad stuff. Queues are bad. And that doesn't mean you don't have any. You need this buffer to make sure there's always some work, but you make them short. Yeah?
I didn't get the idea how the improvement process is really applied. Because in Scrum, you know, you have the retrospective, you get together, you say the good, bad things about the process. But in Lean,
okay, so let's talk about Lean. So let me just do a scenario for you, okay? So in a classic process for improvement process, a team in a work area would get together and they would not have a list of everything that's wrong. They would have a list of 5 or so things. And they would do a Pareto chart. Is there a... Nothing for me to draw on, so I'll draw on here. Okay. So... Yeah. Sounds like a plan. So a Pareto chart... Here, could you... Like, get rid of that? So a Pareto chart works like this. You have, what did we do? Oh dear, we pulled off the, it's got cool. It's got about a 2 minute cycle time. So much for that. So a Pareto chart is you have a problem. You get your team together and you say, okay, so what are our biggest problems? And you might pick 3 or 4 of the people think are big. And the next thing you do is measure. Okay, you say, okay, well, we think these are problems. Let's find out which ones of these 3 things are actually sending the worst defects to production, or are actually slowing us down the most. So you have a criteria, and you don't just talk about this is bad. You measure the impact of your 3 or 4 or 5 things, and you decide which one has the highest negative impact on your current ability to do things. And you limit yourself to that one, okay, as a team, And then you take a classic process improvement process and say, okay, here is our biggest problem. Right now, we are not having any kind of, we're not stopping when we have test failures. So what are we going to do about it? Then you come up with several plans, one or two, and you test whether or not you say, our goal is, starting, say, 2 weeks from now, we want, whenever we find a test failure, we want to have a way to withdraw the code, to back out the code. We want to have a process in place so that the code will get backed out as soon as we have a test failure. So we have to think of a way to do that. So you start out with that, which is here we go. Oh, no, I don't need it. So you start out with a bunch of ideas of how can we always stop when the tests don't pass. And you try them. You try some experiments. You say which one works the best. And after the team has focused on this concept for a week, or for 2 weeks, or for however long it takes, and that problem is solved, then you go back and you do another Pareto chart. Pareto chart is you take problem A, B, C, D, E, and other. Okay, so let's say it's system integration testing time. And you have defects. And you have a defect caused by defect type A, defect type B, D, a couple of others, a few C's, an E, a couple more B's. Okay, those are the kinds of defects we're finding in system integration testing. And it turns out, after you go through one systems integration test cycle, you discover that defect type C is the biggest defect you're finding in system integration testing. That's step one. That's a Pareto chart that says, what is our biggest defect type? Then you take C out, and as a team, you say, we're going to kill C. We're not going to have any more C defects. We're going to ignore A, B, D, E, and other for a while because we're going to focus on C. That's our biggest one. We're going to find a way not to ever have any more type C defects. Now, that's not easy. It might take 2 or 3 or 4 weeks, but we're going to get rid of type C defects. Once we've done that, then we come back to the next systems integration test and we figure out again what's our biggest defect getting through. So that's what I mean by a classic process improvement process. The team does a careful study of the biggest problem with counting or something like that, or impact counting, and they choose the one that is the most important one to focus on, and they ignore the others while they work on that one until they kill it. And then they go to the next one. And they just methodically, one after another, kill it. So in retrospect, as you talk about what's wrong, in process improvement processes, you kill the most important thing that's wrong. That's what your objective is. And you don't stop until you've killed it, or at least, got it flat on its back. So you take the time necessary to get rid of that one problem, and then you go on to the next biggest problem. And your team sets aside time, maybe a couple hours a week or whatever, to focus on getting rid of that problem. And that's the difference between retrospectives and process improvement. Your team just methodically gets better. There's no option.
Sometimes people get a little bit lost coming from Scrum, not to talk coming from Waterfall, coming into Lean, because they feel a little bit lost. They say, well, but I want to know exactly what to do in this and this situation. What Mary is saying here about dealing with C may seem obvious to many people, but in many cases people say, well, it doesn't matter if you're dealing with C or with others or with E. As long as we're solving a problem, it doesn't matter which one it is.
It does too.
But it's not the same, because what Lean provides is a set of principles. Basically 7 ideas, 7 main core concepts. One of them is eliminate waste, for instance.
Right.
And it sounds simple, but to define what is waste, everything that does not mean add value to the final customer at this real moment, only when you go deeper into this concept, then you can find out that code is waste, that's work in progress, is waste. And you can never get rid of that, but you can reduce it. And the more you reduce it, the more value you produce.
Yeah, the other thing is, the reason why I said one thing at a time is because guess what? If you do 5, you've got a queue.
Yeah.
You've got a list. I'm sorry, but this concept of cues are bad is really a big concept. You don't get it until you've tried it. But think about this. When I have a list of stuff at the end of a retrospective, what is that? It's a queue of problems. What good is a queue of problems? You can only work on one thing at a time. You may as well pick the biggest one and focus on it. And quit talking about all those other things unless you actually intend to do something about them. Unless you have a method to make sure that they are addressed. Okay, talking about problems isn't good enough. Now, there are plenty of teams that do retrospectives and improve, but there's plenty of teams that don't. Okay? In Lean, the improvement, the fact that you constantly get better, and very, very standard processes to do it are pretty much part of the package. There was a question there.
No, but in the retrospective, after you get all your list of things to improve, you are expected to select just a few of them and to focus and get the commitment of everybody that you will have.
And how does that work?
It works.
Sometimes it works. Oftentimes it doesn't.
There's people that they didn't even check in the next retrospective if they did anything or not, but in general...
Okay, so if you actually make a workable, constant improvement process out of retrospectives, that's great. But if you're looking at Lean, the processes that I use always in manufacturing were much more methodical than the let's get a list and think of how we're going to which ones. So I personally am experienced with much more methodical improvement processes than a retrospective. I was at a big company, very big company actually. I won't tell you which one, and they were showing their Lean Agile process to people, and they would always put the retrospective book up there, put a big red X through it, and say, "This is very weak. Let's do some really, some standard process improvement instead of this, watered down version of it." And that's what I always think of as retrospectives. Yes, they can work, but they're a watered down version of the kinds of standard process improvement processes I grew up with in manufacturing plant. So
the improvement column that Mary ended with is a little bit more subtle than what she presented. First thing is that every person going through the kata cycle has a teacher, a mentor. That mentor is usually their lead or their boss. So your supervisor, your manager, your lead is your teacher that helps you learn how to do the problem-solving process correctly, how to do good problem identification, which is the hardest part, how to do sound root cause analysis. What is the cause of the cause of the cause of the cause of the cause? 5 whys or other techniques. How you gain a consensus among the people whose behavior has to change to make this problem be improved. How do you do formulate experiments that will verify that your analysis of the cause of the problem is correct, or that a solution that you might think would work actually makes the situation better? And when you do, of course, then you change the way the group of people who are affected work together, adjust your standards so that you have a more effective way of working from which you can do the next cycle. The other aspect of that, though, is that this happens at many scales. For junior people, newbies, you typically will address simple problems. It may be as simple as training in new techniques that the learner doesn't know yet. It may be that the way we've been doing our unit test automation sometimes has glitches. So let's figure out a way to improve the script that we're using so that these kinds of glitches don't happen again. That's the introductory level. The second level tends to be more dramatic or difficult. These tend to be things that are undertaken by a group of people. Kaizen projects, improvement projects, even product development fall in this category. And this category results in significant changes bringing in a whole new version control system to across several teams is a possibility. Bringing in a continuous deployment system that will change the way we do our experiments and improve our product design. It's something that would take a number of weeks, maybe a number of months. And then finally, there's the more senior group of people, and they undertake more difficult improvements. They will undertake improvements to the way the organization functions, support improvements. How do you hire people? How do you help them grow? How do you organize the work in order to achieve the goals of the organization? And these tend to take much longer time, months or more, because the experiments take longer time to perform and to see the impact. So it's much more complicated than just a four-step process, but that four-step process is how all of the tools that Toyota used that people try and copy were invented using that four-step process. And people that try and copy those tools are fools, because they are Toyota's solutions to their problems in their context. And you have no reason to believe that they will be your solution to your problems in your context. We gave a talk at a Agile conference in, I think it was Tokyo. And Mary gave a keynote speech with all sorts of good things that she said. And she was followed by a Toyota person. And the first thing he said was, don't listen to what Mary said. Think for yourself.
Yep.
And we hardly endorse that. Don't listen to what we say. Think about the points we've made and figure out what does it mean in your context. Think for yourself. And we're not saying your own opinion. We're saying your own experience, your own measurements, your own data, your own experiments. That's where you get your truth from. Not from listening to fancy books or fancy speakers.
So I was just going to sum up. These are the 7 principles that you were mentioning. And I think you'll see that I talked about eliminating waste, especially extra features. I talked a lot about building quality in because I just don't think we emphasize this nearly enough. About learning, not doing what we're told, but learning what's important. About speed, forget cues, because cues are what keep us from having speed. About getting everybody engaged. I didn't talk a lot about that because you know what? Agile does a pretty good job of that. And constantly getting better. And I didn't talk as much about optimizing the whole thing as I could have. But this, think about the whole system, not just the software, I think is really important. There is nobody out there that wants software. I'm sorry. If our customers could get their problems solved without software, they'd be just like really pleased. There's nothing that we do in software that our customers care about. And we got to learn to care about what they care about and make sure they get that and make sure that our software delivers that. And then we have to make that our job, not somebody else's job to tell us. We have to make it our job to understand what's the big picture and how can we make sure that happens. How can we make sure that our software has the impact, not that even our customers want, but that it can have. So we have to think even deeper than what our customers are saying to us, than what they would say in focus groups, than what they would say if we'd ask them. We have to understand their problem and say, what do we know about technology that can be brought to bear on solving that problem even better than they could imagine? That's what we need to do, and we're really good.
We have to stop delivering passenger horses. Henry Ford said, if I had asked my customers what they wanted, they would have told me faster horses.
No more faster horses. Let's start making cars. More questions? It's 8, so I don't know.
Yeah, we are. I mean, it's also our last day with you both. So.
Yeah, I'm flying.
Somebody has one more question.
We're flying to America tomorrow, so to U.S. tomorrow. more questions? There's one.
When you were talking about the artifacts and the specification as an artifact and stored somewhere, is it possible that you were talking about, I imagine, the Gherkin language, SpecFlow, Cucumber, that sort of tools that allow you, the people, to make executable specifications?
That's one approach. What we find is that companies that have regulatory compliance requirements have already learned how to write testable specifications, and they won't necessarily be in Cucumber or a language like that. So that's a way to do it. But what you're adding is concept of specification by example. So you're not specifying every detail, you're saying, here's an example specification. If this happens, I want that. Those are very good specifications too. It's going to depend on the domain. My observation is that testable specifications, TDD is pretty much language specific, but specification by example is pretty much domain specific. So whether Cucumber works for you will depend on your domain. Each domain will develop either good languages or sometimes domain-specific languages that will help solve the domain's problems and specify correctly. And we need to be looking for those. In generic enterprise software, Cucumber is probably not a bad idea for those kinds of things. But when we get really specialized domains, that might not be the right one. Look for something else. Every company we've dealt with that's good, that does any kind of regulated software, where they're going to have inspectors come in and check them out because it's safety critical, has developed some way of doing automated executable specifications because they can't afford not to. So this is a problem that the aircraft industry solved 20 or 30 years ago. Medical device industry solved a decade ago. And we can do this. It's not, the tools are becoming more available, the practice is becoming more common, and so we should be able to know that our software should do this and does in fact do that with a high degree of certainty and use those as regression tests so that we can change our software frequently. So we got to get over this idea that software is hard to change and to think of everything up front. We just have to get people way past that. That is a very archaic concept. There's way too many people who still think it's true, but it's just wrong. And so we got to get the world past that idea, but we only get them past the idea, I think, with not just Agile, but also making sure we do the right thing and making sure we deliver quality all the time. And not have this big back-end testing and these really long development cycles. They got to see the benefit. They care less about what our process is or what we call it. They want stuff fast that works, that is solid, that isn't going to bite them next week, and solves their problem. That's when we got to start learning how to deliver and thinking about that rather than thinking about the process that we use.
One of the most challenging titles of the books they wrote, that for me was very hard to grasp by reading it, until I got the book, was that results are not the point.
Oh yeah.
Because everything I read until then was that everything is result-oriented. As long as the results work, then this is what we are going for. Especially optimize the whole. Let's look for the final result and get it done. So it's not possible in 1 or 2 days to cover all things. It's good that you leave also with some questions.
12 years to write those books.
But I think it's good also that we can say a big thanks to Tom and Mary for being with us. They have had, I think, a very good time also with all of us.
Yes. We really enjoyed being here.
We also expect that, this is not just a nice conversation. It's good that you leave also with some questions, and you, like Tom was saying, we start also thinking for ourselves. We're a small country, and we tend to copy a lot from what is coming from the outside, and to believe that this is better than anything that is done here. The other day, and also here when I was trying to put this lean, and on top of that I was putting you, I was mentioning to them a story from Mafalda, maybe some of you have read that, in which Libertad is telling Mafalda, you know, the problem we have here is that we are trying to copy everything that US and Europe are doing. And we should not try to copy what they are doing. We should not try to be like them. We have to do like them. They never copy anybody else.
Right.
They are simply like they are. And only once we are like them, and we stop trying to be like them, we will be ourselves. And then all the problems are going to be solved. I don't know if I could say it in English, by the way.
Really
But please try to get this and read
companies
it.
don't copy anybody. They have their own way. The companies I admire, every one of them develops their own way. They don't try to copy somebody else. And so I suggest you try to think about saying, you guys are smart, you can do this.
Thank you.
Fernando the stuff that I showed, and then he can send you. Or you
We'll
can,
publish it in Agile UI. Okay, it's the menu here.
this one over.
From there can be downloaded probably. Maybe published. If not,